you done with this?
Sir, you can
Now see.
finish it.
Nitrous acid at 0 to 5 degrees centigrade. If you are going to react this benzenamine, then we will get a diazonium chloride, diazonium salt, that will be N2 plus Cl minus, N2 plus and Cl
Cl
minus.
minus because O Cl will replace O2.
With yes, then the product form Cl will here it and this will release and be in the
So, sir, you are lagging a lot, sir. I can't hear you.
Harsh, am I able to?
Sir, you're still lagging, sir. Like I can't let
Harsh,
you hear.
wait. Am I able now?
Yes, sir, you're audible. But there is still
Harsh?
lag. Like there is still lag, sir. You're audible, but there is still lag.
Okay, I'm going to change the network.
Yes, sir.
Harsh? Harsh, you're audible now.
Yes, sir, you're audible,
Yes,
sir.
like
You're audible, sir.
now see, this is basically I'll just change the network, don't worry. Sandmeyer's reaction. Have you heard of it?
Sandmeyer's?
This is Sandmeyer's reaction.
Yes, sir, yes, sir,
reaction.
yes, sir. We learned about.
So in the same way, if you are going to prepare this, it will be Cl and okay. Please write all this. I'm changing the let me know when you are done with this.
So done, sir.
Thank you.
So, sir, I just have a question.
So yes.
Sir, like my father talked to you yesterday, right?
Yeah.
So, sir, you're taking extra classes for me, right? Because I'm like we miss some.
Yes, there will be.
There will be.
Yeah. Now tell me,
Yes, sir.
What's going on in your school? How much syllabus is covered?
So school they started alcohol, phenols, they completed one topic and they left because summer vacations are going on, right? Because after this chapter, they just, it's like nothing is any tell. That's it.
Okay. Okay, no problem. Now see.
Yeah, yes, sir.
Do you have any doubt in the previous lectures or anything?
Sir, just a minute, sir. I'll go through 1 minute.
I just switched off my video because of internet connection.
Yes, sir. Sir, after this, how many topics are left for this chapter?
This chapter is almost covered.
And after this, we have that rate DI.
Reaction of basically chemical properties of haloarenes, in
Yes,
which
sir,
there will be
chemical
resonance.
And then the last part, PP dichlorophenyl and the pherones.
Yeah, this all are very easy.
Yes, sir, those are easy. That's the last part, right? Done.
Done.
Yes, sir.
Now, since we have already covered the topic, that is elimination reaction. Now the next chemical properties is reaction with metals. Reaction with metals. Reaction with metals. Now you have to focus there. This reaction with metal is very important because we will use Grignard reagent. We will use Grignard reagent, which is also known as organometallic compound. Organometallic compound. See, what is organometallic compound?
Yes, sir.
You can see an organic compound which is connected with metallic bond, that is called organometallic compound. Organometallic compound, and basically RMGX. You can see organic compound and then Mg, that is metal. So this organometallic compound is known as Grignard reagent because it was synthesized by Grignard. That's why it is known as Grignard reagent. Are you getting my point?
Yes, sir.
So basically, there are some organic chlorides, bromides, and iodides. React with certain metal, not with every metal. React with specific metals to give compounds. They react with each other and give a new compound. Compounds containing carbon metal bonds. And that is known as organometallic compound. Organometallic compound. CPD stands for compound. So basically, there is a haloalkane CH3CH2Br which react with magnesium in the presence of dry ether because it is very reactive. That's why the reaction carried in the presence of dry ether, and there will be a product that will be formed CH3CH2 and then MgBr, and this is Grignard reagent. And it is very reactive. Why it is very reactive? Because you can see there is non-metal and there is metal. So the polarity is very high. That's why it is
very reactive.
Can RMGX. You know, metal is positive, electropositive. So it will have delta positive, non-metal delta negative, and delta negative. That's why
Delta negative.
it's very, very reactive. So please write this and then I will explain. Let me know when you are done with this.
Yes, sir. Done, sir.
Now see, since I told you this is very reactive, so I'm going
Yes,
to
sir.
write a point that Grignard reagents are highly reactive. Grignard reagents are highly reactive and react with any source, react with any source to produce with any source of proton, any source of proton to give hydrocarbons, to give hydrocarbons.
Carbons.
Even a small amount of moisture, or if you are going to react it with water, just see what happens. RMgX will react with H2O to give RH, that is hydrocarbon,
Hydrocarbon.
plus MgOHX. Now see, how does this reaction takes place? You know that this is R, this is Mg, and this is X, and you know that this is H2O. So now I'm going to write it separately. That is R delta negative. This will have delta positive. And you know that H2O also has H plus OH minus. Yes or no?
Yes, sir.
Now you know that this positive will go to this negative, and after combining this and this, what it will form? RH, yes or no?
RH. Yes, sir.
RH, it will form
Yes,
RH.
sir. RH.
And you
RH.
can see this negative and this positive MgX, it will combine and it will form MgOHX, because on the OH it is minus, and the X it is also minus, and this is
Minus.
plus. That's all. In
Yes,
this
sir.
way they react with each other.
Okay.
Very good. Please write.
Yes. Yes, sir. Yes.
After this chapter, which chapter we are going to cover?
Sir, in school they started up alcohol phenols, like one topic they did.
Then we will also start alcohol phenols.
Yes, sir. So the chapter will finish today?
Which chapter?
This one, sir.
Most probably. Let's see. In the next class, it will be finished. To be honest, are you done with this?
So just one last one, sir.
Okay. No, wait a minute. Sorry. Just let me know when you're done with this.
Done, sir.
Done. Now see, if I'm going to give you a question on this topic, like this, CH3 MgBr react with H2O. Can you tell me the product hydrocarbon?
Yes, sir.
Tell me.
So it will be okay, sir. I'll tell you the answer after writing those two, sir.
Okay, no problem. Do these questions.
Yes,
Two
sir.
questions.
So the answer to the first one will be CH3H plus
That means
MgOH.
CH4, no? CH3H
Yes,
means that
yes,
means
sir.
CH4,
CH4
and here it will be MgOH.
MgOH. Yes,
And
sir.
this is the main product, CH4.
Yes, sir.
Very good, methane.
So it will be CH6.
CH6.
Sir, for the second one.
C2H6, no?
So CH3, CH2, and then H, right?
See, CH3, CH2, CH3.
CH2 and
It
then
will
H.
be like this, no? It will be same thing. No?
Yeah.
Like
So
CH2H, or if
CH3,
I'm going to
CH.
write CH3, or if you want to write it in short, it will be C2H6 along with MgOHBr. Yes or no?
Yes, sir. So CH3, CH3, Mg plus MgOH.
Done.
Yes, sir.
Very good. Can I change the slide?
Yes, sir.
Now, reaction in metals. With reaction in metal, there is another topic, that is Wood's reaction. And Wood's reaction is very easy.
Okay.
So in this
Wood's
reaction, what
reaction.
happens? Wood's reaction. See, basically we take haloalkanes and react it with sodium. React it with sodium. And it gives you RR and 2 NaX. Basically, we take 2 moles of RX and 2 moles of this, and then RR form with salt. So how does this reaction takes place? So it is very easy. RX. So I'm going to write RX plus Na. I'm going to write Na. And since we take 2 moles of both, so I'm going to write this in reverse form. Can I write it like this? Rx twice. At the place of twice Rx, I can write Rx and Rx.
Yes, sir.
And just remove this and add that Rr. So what you will get in the presence of dry ether, the reaction is also in the presence of dry ether because
Okay.
sodium is very reactive. Dry ether. So the main product, your main product will be Rr with 2 NaOH. Are you getting my point?
Okay, so we replaced X. Sir, can you explain again, sir?
See, in Wood's reaction, whatever is the R, it will be doubled.
Okay.
So how I'm going to explain it? I'm going to take 2 moles of this. That means Rx. One I take
Rx.
it like this, and
Yes, sir.
one reverse of it XR. Can I write it XR?
Yes, sir. Yes, sir, you
Any
can.
problem? And
No, sir.
2Na. There is the reaction is carried. The reaction is reacted with 2Na. So just
Yes, sir.
removing NaXX and just combining these two, it will be RR.
Yes, sir.
And
Oh, we removed it.
the byproduct is
2NAX. Yes.
2NaX.
Yes, sir.
Yes, please write it.
Yes, sir.
This is question number 1, and this is
Sir, so the answer for the first one will be CH3, and then 2NaCl.
yes. We don't deal with this byproduct. That is a correct answer. And the second is C2H5, C2H5. Yes or no?
Yes, sir.
Or we can write CH3, CH2, CH2, CH3, butane, and then 2NaVr.
Yes, sir.
Yes or no?
Yes, sir.
Please write it. So tomorrow you are free, right?
Sir, tomorrow evening, sir, I have tuition.
No,
sir.
no, in the morning.
Tomorrow morning, I'm free.
At noon, basically at noon.
Sir,
I
can you
think
repeat?
at noon you are free.
Sir, in noon in morning, in better, sir, you can take in morning, sir.
Morning. Okay. At what time?
Sir, you tell me the India time, sir. I'll tell you from here.
Okay, 10 a.m.
means 7:30. Yeah, I can do it.
Okay.
Yes, sir, you can take it 10 a.m.
Okay.
So
Is it done?
yes, sir. So for the same duration, sir, 1.5 hours.
Yeah.
Okay, sir, you can take.
Because by tomorrow we will complete this chapter.
Yes, sir. You can take.
Alcohols, I think we should complete in this month too. Okay, now see, right to topic. Reactions of haloarenes. Reactions of haloarenes. And before starting haloarenes, I'm going to give you this chlorobenzene, and you are going to write the resonating structure, write the resonance, all the resonating structure of this. Can you do this?
Yes, I'll try, sir.
Yeah, very good. Wait a minute. Just removing the double bond to place it.
Chlorobenzene.
Do you know how to do resonance, right?
Yes, sir.
Very good.
So we should have the resonance structure of chlorobenzene. Okay.
Yeah. Can you do this or?
So just a minute, sir. Sir, I did it. Can you show? Is it correct?
Yes. See. So for the resonance, there is a condition. Uh, it will be like it will go and form bond here.
Yeah.
Since this
Yes, sir.
carbon is already making 4 bonds, so this bond we will break and put it here. Now you can see
Yeah, we'll shift
there
the
will
bonds.
be negative charge here.
Yes, sir.
There will be negative charge
Yes,
here.
sir.
Yes or no? Now here it will be positive charge, but at the same time this lone pair comes here, so positive negative cancel,
Yes, sir.
and this is single bond. So I'm going to
Yes.
make it double
Yes, sir.
and Cl, and there will be positive charge. Yes or no?
Yes, sir.
Now this will go like this and this at this. So you can see there will be negative charge. There is double bond, double bond, double bond, Cl positive. In the same way, just move it. It will be here. Now the negative charge is on. Here there is the negative charge. Double
Yes.
bond, double bond, double bond, Cl positive. Now move this here and it will here. Now you will get the final. It will be like this. So this is the resonating structure of this. And you know this and this, wait a minute. And you should know this and this are similar, same, okay?
Yes,
So
sir.
if there will be a question, how many resonating structure? 1, 2, 3, 4 only, okay? 4.
Yes, sir.
Are you getting my point?
Yes, sir. Yes, sir.
Now there is a point which is very important. I'm going to write, wait a minute. Alkyl alkyl halides are extremely less reactive towards nucleophilic wait a minute, towards nucleophilic substitution reaction due to following reasons. I'm going to write the reason. Due to following reasons. So basically we are studying reaction of haloarenes. In reaction of haloarenes, it is nucleophilic substitutes. Then write the resonating structure and then the point. Then I will give you the reason. Please write.
Yes, sir. Done, sir.
Also, Harsh, are you there? Harsh, Harsh. Okay, okay, yes. What is the problem? Okay, okay. I'm waiting. Just message. No problem. Just leave and just join. I'm waiting. Harsh, are you there? You are not audible. No, not at all. Am I audible to you? Okay. So see, you just reply me in chat box. Why aryl halides are extremely less reactive towards nucleophilic substitution reaction. If you are going to react it with the nucleophile, there will be no reaction. Almost there will be no reaction because it is already stable. Because it is already stable, that means you can see there is a lot of reasons, 3 or 4 reasons. The first reason basically due to partial double bond character. I will explain it. This is partial double bond character. Due to partial double bond character between C and Cl. You know, single bond is weaker as compared to double bond because it is there is two bond. You can see there will be Cl and C. The bond between C and Cl will be partial double bond because due to resonance, this bond will be first it was single, then due to resonance it will be double, then again single double. That's why it is partial double bond character. That means it is a partial double bond character. Partial double bond is more stronger than a single bond. Okay, so due to partial double bond, this bond to break this bond there will be more energy needed. That's why are you there? Harsh?
Sir, can you hear me?
Yes, now I can hear you. Am I audible to you?
Yes, sir. Sir,
So
actually, I
you
got
see,
disconnected.
okay, no problem. This is nucleophilic substitution reaction. So for a nucleophilic substitution reaction, you know that there will be a nucleophile which will attack at a electrophile position,
Yes, sir.
electrophilic center.
Yes,
But
sir.
aryl halide is very extremely less reactive towards nucleophilic substitution reaction. Why? Since you can see in chlorobenzene, then it is highly stable in this form due to resonance. It is single, but due to resonance, it has partial double bond character. So it is not easy to break this and make a electrophilic center. First reason is this. Then the second, due to instability, due to instability of phenyl cation. When chlorine will live with Cl minus, there will be positive charge. There will be positive charge on the benzene ring that is called phenyl cation, and it is highly unstable. Highly unstable. So if it is unstable, that means it will not go in this. That's why this is the second reason. Please write it.
Yes, sir.
Now the third reason is due to S character of carbon, that is sp. It also depends on this. Please write all these points.
Done, sir.
Okay. Now see what is S character. You know sp3, sp2, and sp. So we are going to see S character. Since here, how many orbitals are involved? 4. Yes or no?
Yes, sir.
So each orbitals will have 25% of contribution. Yes or no? 4
Yes, sir.
orbitals, 3p and 1s. Here you can see 3 orbitals. So S character will be 25%. Here it will be 33.3%.
33.
And here it will be 50%. Yes or no?
Yes, sir.
Always remember that S character increases, electronegativity increases. And if electronegativity increases, that means there will be polarity. Polarity, you know, positive, negative, which will have electrostatic force of attraction. So due to S character of carbon, it is also it is also the reason for aryl halides very less reactive towards nucleophilic substitution reaction. Is that clear?
Yes, sir.
Okay, please write it. And the fourth reason, which is also very important, is electron rich phenyl ring. So basically already phenyl ring is electron rich, and if there is another nucleophile, that means electron rich compound, there will be probably repulsion. Are you getting my point?
Yes, sir.
That's why Aryl halides are very less reactive towards nucleophilic substitution reaction. And to carry this reaction, we need conditions. There will be
Yes, sir.
condition like high temperature, high pressure, then the reaction will occur. Then the reaction can carry out,
Yes,
but
sir.
it will not carry out at room temperature. Are you getting my point?
Yes, sir.
Please write.
So done, sir.
Then very good. Now see, tomorrow the chapter finish. Okay, here
What,
it
sir?
is basically. This chapter will be completed in tomorrow class.
Yes, sir. You told me.
Replacement by hydroxyl group. Replacement by hydroxyl group. Now you can see replacement by hydroxyl group. So if we have chlorobenzene, in which three lone pairs on chlorine,
Yes, sir.
and react it with NaOH, sodium hydroxide, at 623 Kelvin
Yes, sir.
and 300 atm pressure.
Yes, sir.
And the second is H plus. In the second in the second step, you are going to mix it with acid. Then there will be phenol formed. Then there will be phenol.
No.
Now I am going to explain the mechanism of this. How does this reaction takes place? Am I audible?
Yes, sir.
Okay. So this is basically Dow's process. Dow's process. So what does this Dow's process? How it carries out? How it's go? Like say you are going to react this chlorine with aqueous NaOH in the first place. Aqueous NaOH. The condition will be same at 623 Kelvin and 300 atm. I'm going to are going to react it with H plus. So what happens here? OH minus here, it is OH minus and temperature is abruptly very high and pressure is also very high. So OH minus will go and attack at this position and Cl minus will eliminate from here. So what will be the product here? It will be basically OH like
Oh,
this. Now again, you are going to react this with NaOH. NaOH. So what happens? This H plus from here, it will go Na plus comes and go with O minus. So it will be basically O minus Na plus. O minus Na plus. You can see OH has minus sign, Na has plus sign. So positive will attract towards negative and negative will attract towards positive. And again, you are going to dip this in H plus and it will form the final phenol. Okay. So basically this should carry out because see, already we have formed OH, that is phenol. Again, why NaOH react with phenol? Because whenever there is alcohol and NaOH, they will react with each other to salt this phenoxide. Please write this.
yes, sir.
So chlorobenzene, are you done with this? Let me know when you are done with this. Are you done with this? Harsh, Harsh, are you there? Harsh, Harsh, are you there?
Yes, sir, I'm there, sir. I got disconnected.
No problem. Now
There's
you
some
can see.
problem with network.
Okay, are you done with this? Or
Sir, I was
are
writing,
you
sir. I got
writing now?
disconnected, sir.
Okay, okay. Please write it. Let me know when you are done with this. Very good, Harsh. So basically, this is Dow's process. So in Dow's process, chlorine is replaced by hydroxyl group. Okay. Now, you know what? Chlorobenzene is more reactive when there is withdrawing group attached with that. Like I'm going to write a point. The presence of an electron withdrawing group like NO2 at ortho and para position increases the reactivity. Increases the reactivity of haloarenes. Harsh, are you there? With a single chlorobenzene, since it is electron rich, so nucleophile cannot attack on it directly unless or until there will be a drastic condition like very high temperature and pressure. So what we do to replace chlorine with OH, we just add NO2 at para or ortho position, and this NO2 will decrease electron density in phenyl ring. And that's why if there will be decrement in this ring, a nucleophile can easily attack on that, and the reaction condition will easily decrease. We can easily carry out the reaction like NaOH in the presence of NaOH at 443 Kelvin, and in the second step H plus. So it will be NO2 and OH. Please write it. Harsh, are you done with this? Harsh, are you done with this? So see, with the connection of NO2, when you are going to place one NO2 on para position, see the condition changes. The condition is quite good. And if you are going to place two NO2, one at para and one at ortho, the condition also decreases like this. You can see in the second place you are going to add, and the product will be the replacement of chlorine by hydroxyl ion is very easy now. Please let me know when you are done with this. Are you done with this till this? And if you are going to add three nitro group, if you are going to add three nitro group, this is Cl, and you are going to add NO2, NO2. NO2 is a electron withdrawal group, and it will withdraw so many electrons. It will withdraw with a very high power. Since there are three NO2 group, the electron density in the ring will decrease, and then nucleophile can easily attack. So if you are going to just add this in warm water, it will be easily replaced. Please write this. Let me know when you are done with this. Very good. Now see, I'm going to start a new reaction, that is electrophilic substitution reaction. Electrophilic substitution reaction. So in the electrophilic substitution reaction, there is first, that is halogenation, means simply addition of halogen. So I'm going to write a reaction. Chlorobenzene is here, and we are going to add Cl2 in the presence of anhydride FeCl3. Anhydride FeCl3. It will be converted into Cl on para and Cl. With respect to each other, it is on para position one of the chlorine, and one of the chlorine will be at ortho. Since the resonance has no effect on meta position, that's why. And this is major product and this is minor product. Can you name it? Can you name the product? You take name.
Hello, sir. Can you hear me?
Yes, yes. Can you name it? This and this?
So just a minute, I'll write this and name it, sir.
Okay. Are you done?
Yes, sir. The first one is
What
one
will
three
be its name?
chlorobenzene, 1,4
No,
chlorobenzene,
1,4 dichlorobenzene.
yeah, 1,4 dichlorobenzene. And the
Dichlorobenzene.
second one is minor product is 1,2 dichlorobenzene, right?
Yes. 1,2 dichlorobenzene.
Benzene.
So in electrophilic substitution reaction, you can see this is halogenation. And the second is nitration. Are you done with the first one?
So just a minute, sir. 1 minute.
Okay, take your time.
Done, sir.
Are you done with this?
Yes, sir. Yes.
Now see, nitration, that means we are going to add nitro group in chlorobenzene. And how we will add? We are going to react chlorobenzene with HNO3 in the presence of concentrated H2SO4. So with respect to chlorine, NO2 will be added at ortho and NO2 will be added at paraposes. Can you name this? And tell me which one is major and minor.
Sir, the second product is
This
major.
will be minor.
Yeah, second product is major.
This is major.
Yes, sir.
Again, the name will be one, two. It will be one chloro,
Two
nitrobenzene,
two
nitrobenzene. And the name of this, you can see 1, 2, 3, 4. One chloro, four
nitro
benzene.
benzene.
Please write it. Please let me know when you are done with the above one, nitration.
Done, sir.
Very good. So this is sulfonation. Sulfonation. We are going to add sulfonic acid. So sulfonic acid with respect to Cl, SO3H on ortho, and with respect to Cl, SO3H on para. So the name will be 1, 2 because it is a functional group and it is senior most functional group basically. So the name will be 2-chloro-benzene sulfonic acid. And here you can see 4-chloro-benzene sulfonic acid. Tomorrow we are going to end this chapter and to start alcohols. Okay. Let me know when you are done with this. Please let me know when you are done with this. Harsh, are you done with this?
Sir, I got disconnected. Sir. Can you explain that again, sir? I was disconnected the whole time.
No problem. Now you can see
Last one, sulfonation.
this.
Yeah, sulfonation, sir.
Sulfonation, we are going to add sulfonic acid. So you are
Okay.
going to react this with concentrated H2SO4. So SO3H will be added at ortho and para position. And is measured, this will be measured, and this will be minor product. And I wrote the
Sir, you're lagging, sir. I can't hear you.
Please write it. Am I lagging now?
Yes, sir.
Wait a minute. Write it first, then I will explain. Harsh,
Yes, sir.
write it.
Done, sir.
It's
Done.
just that we are going to add H2SO4 in the and heat it. With chlorobenzene, we will get SO3H at ortho and para. And I just wrote the name of it. Okay.
Sir, so SO3 is sulfonic acid.
It is sulfonic acid. And it is the senior most functional group, more than carboxylic acid. So the name will be 2